Okay, this is Project Test 7, video number 1, and we'll be covering problems 1 to 10. So the histogram summarizes the responses of 100 people when asked, what was the price of the last meal you purchased? So basically, for each one of these, we should be able to add them all up and we'd get to 100. Based on the following, which could be the interquartile range of the prices? Well, remember, IQR equals Q3 minus Q1. So in this case, Q3 or Q1 is going to be the 25th person and the 75th person because they're percents. Since we're just taking it out of 100, they'll be the actual number because 75% of 100 is 75, 25% of 100 is 25. So I need to find those on the graph. All right, so where does the 25th person occur? Well, 8 plus 13 takes me to 21. So somewhere in this column right here, somewhere in this column is the 25th person. So 8 plus 13 is 21. And we know that in this column, and these, if we notice, we are changing by 4. So somewhere between 9 and 11. So somewhere between 9 and 11. So I'm just going to take the center point as an estimate as 10. It could be anywhere from 9 to 11. We don't know where, but anywhere between $9 and $11. All right. So that takes us 8 plus 13 plus 11 takes us to 32. Plus I add 14 more. That takes me to 46 plus 22 more. And I'm at 68 plus 8 more. And that takes me to 76. So in this column right here is the 75th person. All right. Well, that column goes from a low of 15 to 17. So I'm going to call it 16. And once again, it's 15 to 17. Well, 16 minus 10 equals 6. So I'm looking for an IQR somewhere around 6. It can be more than that. It can be a little bit less than that. But in this case, 16 minus 10 is 6. And the one that's closest is letter D. And so number $5 happens to be the closest. And once again, we can't be exact because we don't know where within the column it occurs. It could be as high as 17 or as low as 15. This one could be as low as 9 or high as 11. All right. So technically we could go, if we wanted to, we could take 17 minus 9 and get 8. And we could go 15 minus 11 and get 4. So we know that somewhere between 8 and 4 is the IQR. And all I did was the highest value was 17 and the lowest value, was 11. That's not 8. That's nice. Let's try that again. 17 minus 9. 17 minus 9 gives me the 8 because that's my highest and that's my lowest. And then my lowest over here, 15 minus 11 is 4. And so this gives me the range of values somewhere between 8 and 4. All right. And so the only one that lies in that range is 5, or lies within that interval. Okay. Number 2, suppose a certain scale is not calibrated correctly, and as a result, the mass of any object is displayed as 0.75 kilograms less than its actual mass. So basically, we weigh the scale and it weighs X, but it's actually weighing it 0.75 less. So our actual equals the weight of the scale minus 0.75. What is the correlation between the actual masses of a set of objects and the respective masses on the same set of objects displayed by the scale? Well, as it turns out, the correlation is perfect. All right? The correlation is perfect. Every single point will lie straight on a line. Okay? So my line, y equals x minus 0.75, every single point will be on that, will be on it. So consequently, I actually have a correlation of 1, and the reason it's positive because my slope is positive. And by the way, I actually kind of wrote this equation wrong. It should have been x equals the actual minus 0.75. So the actual equals x plus 0.75. So this should have been a plus sign right up here, not a minus sign. If I had 75, so this is basically saying my slope is 1 and my y-intercept is 0.75. All right. A veterinarian collected data on the weights of 1,000 cats and dogs treated at a veterinarian clinic. The weight of each animal was classified as healthy, underweight, or overweight. The data are summarized in the table. Based on the table, which of the following is the most appropriate type of graph to visually show whether a relationship between the type of animal and weight classification? Well, we see the word classification, and we should be thinking that we're working with categorical data. So I'm going to need some sort of categorical graph. This is quantitative. This is bivariate. So this is bivariate. So, box plots are quantitative. A dot plot is quantitative, but a segmented bar chart is categorical. So in this case, because we're working with categorical data, we needed a segmented bar chart to make the display. Number 4, a program exists to encourage more middle school students to major in math and science when they go to college. The organizers of the program want to estimate the proportion of students who, after completing the program, go on to major in math or science in college. The organizers will select a sample of students from a list of students who completed the program. Which of the following sample methods describes a stratified random sample? So remember, when we do a stratified random sample, we're going to be breaking them into groups and then doing a random selection within the group. Unfortunately, up here, they didn't tell me what groups are, but I'm going to need more than one. So select all female students on the list. No. Selecting all female students would be a census for female students. Randomly selected 50 students on the list. That would give me a random sample, which is not bad, but that's not what they asked for. They asked for a stratified, and this is a random sample. Randomize the names on the list and then select every 10th student. Well, if you select every 10th student, this is a systematic. Again, not a bad sampling type, but not what they asked for. Randomly select 25 names from the female students on the list and randomly select 25 names from the male students. So I've broken them up into groups of male and female and made a random selection. That's what defines a stratified sample. All right. All right, number 5. This is a tricky question. The normal curve shown represents the sampling distribution of a sample mean for the sample size n equals 25, selected at random from a population with a standard deviation of, need to pay very careful attention to that. So this is the standard deviation of x bar, which equals the standard deviation of the population divided by the square root of n, and they've told us n equals 25. All right. So which of the following is the best estimate of the standard deviation of the population of the standard deviation of x? So now they're asking for the standard deviation of x, but here we have the sampling distribution of x bar. So the mean of x bar is 150. And our standard deviation, well, if I look at these are, we have 1, 2, 3 this way, 1, 2, 3 this way. So the standard deviation of x bar is 15. So 15 equals the standard deviation of the population divided by our sample size, square root of 25. And once again, please note, this is the standard deviation of x bar because this is the sampling distribution of x. Had this been the sampling distribution of x, this problem would have changed substantially. So 15 equals the standard deviation over 5. Multiply both sides by 15, and I end up getting E as my answer. Once again, this is tricky. This is because we're working with the sampling distribution of X bar. So this is the standard deviation of X bar. This is not the standard deviation of the population. All right, they were being very tricky on this one. Okay, number 6. 2 random samples, A and B, were selected from the same population. So this came from the same population. To estimate the population mean for each sample. The mean, standard deviation, and margin of error for a 95% confidence interval for the population mean are shown in the table. Which of the following could explain why the margin of error of sample A is greater than the margin of error of sample B? All right, so first off, let's talk about what the margin of error is. X bar plus or minus T star S divided by square root of N. All right, so as my standard deviation increases, as my standard deviation increases, then my margin of error increases. All right, as N decreases, so as S increases, ME increases. As N increases, ME decreases. So just looking at this, I'm going to go, you know what? This has a larger standard deviation, so I would expect it to have a larger margin of error, but it doesn't. So what happened? That means this N must be bigger. So the N for sample B is greater than sample A. The N for sample B is greater than the N for sample A. So the sample size of A is greater? No, we just said it was less. The sample size A is less than the sample size of B, and that is true. Okay, and we know it has to be that case because the standard deviation of A is less than that of B. So consequently, we would expect the margin of error to be less than B, but it's not. So the only way the margin of error could be greater for A is if N was greater for B. Because as the standard deviation increases, the margin of error increases. As N increases, the margin of error decreases. All right. All right, on to number 7. NIOSH's financial literacy project involved comparing the annual sales of companies in Canada and companies in the United States that produce software. Using the ratio of 1 Canadian dollar to 75 cents US dollars, she converted all annual sales from Canadian companies to US dollars. For which of the following will the value of the statistic for the annual sales in Canadian dollars be equal to the value of the corresponding statistic in US dollars? So basically, she's taking the Canadian dollars. She says a US dollar equals 0.75 Canadian. Okay, so if I multiply by a constant, measures of center change, of center, and spread. So measures of center and spread both change. And we're looking for something that's equal. In other words, it doesn't change. So the median's a measure of center, so it's going to change. The standard deviation, measure of spread, it'll change. The mean, measure of center, it's going to change. The interquartile, measure of center, it'll change. The standardized score, that is the same as saying the z-score, and it's not affected by adding constants or multiplying. So adding constants or multiplying does not change this z. So our best answer for number 7 is C. All right. On to number 8. The manager of a restaurant tracks the types of dinners that customers order from the menu to ensure that the correct amount of food is ordered from the supplier each week. Data from customer order last year suggests the following distribution: 18% beef, 41% chicken, 15% fish, 20% pork, and 6% vegetarian. The manager believes that there might be a change in the distribution from last year to this year. A random sample of 200 orders, so we have an N of 200, was taken from all the customers' orders placed last week. The following shows the results of the sample. So this is what we really observed. This is what we expected, or the percentage we expected. Assume each order is independent. For which type of dinner is the value of its contribution to the appropriate test statistic the greatest? And here's what we're doing. We know we're doing a chi-squared equals the summation of observed minus expected squared over expected. And they want to know which one of these is the greatest. Well, if we know what type of test it is, it might help us out. It turns out that we're comparing to an existing distribution. And this is the existing distribution we're comparing to. This makes this a chi-squared goodness of fit test. So what I need to do is I need to go to my stat edit. In an L1, I need to put in the values: 32, 86, 34, 30, and 18. And those are my observed values. So I put my observed into L1, and then at L2, I'm going to put in my expected, 0.18. And hold on just a moment, I'm going to show you a nice little trick. 0.41, enter. 0.15, enter. 0.2, enter. And 0.06, enter. So I've entered all of the proportions, but I have not adjusted for the sample size. So I need to multiply these by 200. And I have pressed second, followed by the number 2. So I have L2 at the bottom of the screen, and I press times 200. I get my expected. In other words, 200 times 18 is 36. 200 times 0.41 is 82. So now I have all my expected values. And if I were showing my work on a test, it would be something like this. The chi-squared equals the summation of 32 minus 36 squared over 36 plus dot, 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 plus, and then 18 minus, we expected 12, and that would be my work shown, and then I'd go ahead and run the test. So I am going to go ahead and run the test, and this is going to be stat over to test, and I'm going to scroll all the way down to chi-squared goodness of fit, or GOF. My observed is an L1, my expected is an L2. My degrees of freedom, I need to count my categories. 1, 2, 3, 4, 5 degrees of freedom equals cat minus 1, categories minus 1. So in this case, 5 minus 1, which is 4. And then I need to go ahead and calculate. And I end up getting a chi-squared value, and not that they asked me for it, but here it is, a chi-squared value equal to 6.67, and a p-value equal to 0.1542. But that's not what we're interested in. We're interested into the individual contributions. And I can calculate them by hand, or it actually gives them to me. That's what the CNTRB is. So the first one is the beef, and it's 0.14. Then 0.19 is the chicken. Contributing a little more is the fish, it's 0.53. The pork is 2.5, but the largest contribution is the last one, at 3, which is the vegetarian. So vegetarian had the greatest impact on my chi-squared value. And real quickly, just so you know, 18 minus 12 is 6. I'm going to go ahead and square that. Then I'm going to divide by 12. And sure enough, that's where my contribution is. Basically, each one of these gives the contribution. All right, so vegetarian 8E is the correct response. For number 9, a company that makes fleece clothing uses fleece produced from 2 farms, Northern Farm and Western Farm. Let the random variable X represent the fleece produced from Northern Farm. So N is given by the X. The distribution of X has a mean of 14.1. And it has a standard deviation of 1.3. Let the random variable Y represent Western Farm. So Western Farm happens to be the Y. The distribution of Y has a mean of 6.7 and a standard deviation of 0.5. We are going to assume X and Y are independent. Let W equal the total weight of fleece from 10 randomly selected sheep from Northern Farm. So we're going to get 10 sheep from here. And we're going to get 15 from Western. Which of the following is the standard deviation in pounds? Well, if it were just the means, I could go 10 times 14 plus 0.1 plus 15 times 6.7, and that would be easy. But because it's standard deviations, I'm going to go 1.3 squared plus 1.3 squared plus 1.3 squared. I'm going to keep doing that. I'm actually going to have to do that 10 times. So that's 10 times 1.3 squared. And then on the Western side, I'm going to have to go 0.5 squared plus 0.5 squared plus, and you kind of get the hint that I'm going to have to do 15 times 0.5 squared. And once I'm done with that, I'll have to come back and take the radical or the square root of that answer. So 10 times 1.3 squared plus 15 times 0.5 squared. My best answer for number 9 is letter C. Number 10. They're trying to trick you on this one as well. According to a report for veterinarians in the United States, 36.5% of households in the US own dogs and 30.4% of households in the US own cats. If one household in the United States is selected at random, what's the probability that the selected household will own a dog or a cat? This right there tells me I'm working with the union. All right. So the probability of dog, union, cat equals the probability of dog plus the probability of cat minus the probability of owning both, which is dog and cat. Well, I start plugging in and I go, okay, this is 0.365 and this is plus 0.304 minus the intersection. Only they did not give us the intersection, nor did they give us any information on how to figure it out. So for 10, as much as we don't like it, there's not enough information. Not enough information is given to determine the probability. All right, and this will conclude this problem.